Welcome back. Let's get into our second deep dive today. It's about languages. So we'll have our chair will be Rajeev from Secureum. Then we'll have Bryant from ApeWorks. Next we'll have Grant and Alex from the Ethereum Foundation. Charles Cooper from Vyper. And finally, Harikrishnan from Spearbit.
Thanks, Lucas. So this is the first deep dive of the TrustX event. So we're really supposed to dive deep into the code. And we couldn't get a better set of people to dive deeper into Solidity, Vyper, tools, than the people that we have here. So thank you all for joining. We'll start. So we have 45 minutes. Just a quick refresher. We have 45 minutes for the session. We're going to leave the last maybe 8 to 10 minutes for questions from the audience and maybe from Twitter as well, if there are ones online. But I would like to first, again, this is languages, right? So in this context, when people think of Ethereum, when people think of blockchains, it's smart contracts, right? So we're talking about the smart contract languages. So we have representatives of Solidity, Vyper, Fee, and many other aspects as well. So I'd first like to request everyone to introduce yourselves very generously. Talk about yourself, talk about your projects, talk about all the cool stuff that you've done, you're doing, you want to do. Let's start with that. And Brian, why don't you go first?
All right, so my name is Bryant. I'm the CEO of a company called ApeWorks, and we're building a Python-based smart contract development framework, trying to take over from Brownie, if you've used Brownie before. And we're specifically targeting the framework towards smart contract developers, data scientists, and security professionals. So check us out.
Fantastic. My name is Grant, and I work at the EF, and I'm working on this project called Fee. It's a language that takes inspiration from Rust and to Python, mostly Rust nowadays. The compiler is implemented in Rust, targets EVM, statically typed. We have a module system pretty similar to Rust. We call them ingots instead of crates. Just writing a language day by day. It's still a pretty small project. We're kind of just flying under the radar now, but just trying to do cool things. That's about it.
My name is Alex, and I've been working on mostly Solidity at the foundation, as well as a team called Epsilon, which previously was called EWASM. And of course, in Solidity, mostly doing like language design, language research, and in Epsilon, we're doing EVM research. And it's kind of like in between, trying to bridge the gap between like the core devs and the language. And recently also did some contracts just to see, get like a feel for the language, because the team was kind of like one-sided, looking at the language from a language design perspective as opposed to from a user perspective. So trying to bridge, these three gaps.
Hi, I'm Hari. I mainly worked on the Solidity compiler for the last 2 years. Nowadays, from the compiler side, I work on mainly the language design. I'm also involved in building Spearbit. It's a Web3 like auditing firm. Otherwise, I am a mathematician by training. I like also building mathematical solvers, which somehow seems to intersect with building optimizers right now.
Hi, I'm Charles. I work on the Vyper language and compiler. I work on everything from the language design to the, all phases of the compiler through code generation. And my goal is to, make compiler engineering cool again. So I think get people excited about compiler engineering, teach them about it, I guess, and also make Vyper a really easy to use, really user-friendly and a very good language in terms of, efficiency and writing smart contracts in general.
Awesome. Well, I did ask you all to sort of generously introduce yourself, but I think we have finished the entire set of introductions in less than 5 minutes. So we're going to have a lot of time to really dig deep into the language, into optimizations, into the mathematical aspects, into tooling. Languages get very religious. And I've been, sort of in and out of different kinds of languages for a long time. So the format is flexible, but what we had in mind was we'll have one direct question to each of the panelists. So feel free to answer it in depth, and then others can chime in. It's a pretty small group, so we can share the microphones, and we'll mix it up as we go along, right? So maybe let's start with Exec, right? So, like you said, like you introduced, you're the co-lead for the Solidity project, and you've been sort of designing, the whole sort of length and breadth of the language design over there, right? And you've been doing this for a long time with the team. What do you think of, this is a security session, security conference, right? So we're going to talk a lot. We're going to start with security at least. What do you think of the security features of the language itself? This is a very hot topic. People are very quick to point fingers to the language, to the block, up the stack, right? And the first thing when you look at smart contract exploits are, well, if you're technical, you start looking at the smart contract, and then people point fingers saying, oh, this language, oh, it should have been like this, right? And they don't know what it takes to design the language, the security aspects of it, right? So when you look at those aspects from Solidity perspective, what do you think? Are there aspects, if you could travel back in time, are there aspects that you may remove from a security perspective? Would you add, default bounds checking, in 0.4.0 or something like that? What do you think of that?
I could go on for like the entire 45 minutes.
Please. I'll stop you, but yeah, you can try.
But maybe I would just take a step back and maybe explain the origins and the reasons why things happened as they happen, because it may just make it more clear, why it is like it is. So I think initially, when like Ethereum launched, it was like so many brand new system and things at the same time, that if you didn't, it's hard to tell, right? Because what happened, and we don't know if it would have been different, what would have been the outcome. But in retrospect, it seems like that maybe these design decisions, like the initial ones, were the right ones, where you had all these like complexity in the system and newness. And the original designers of Solidity, they tried to dumb it down and make it like, the single piece of the stack, which was more familiar to the outside. So they decided to make it somewhat similar to JavaScript, because you not only have like the smart contract side, you also have like the front end side and back end. And what are the front end back ends written in? They're, kind of like JavaScript-like languages. So they made this choice to make the smart contract also similar. Definitely was probably a good choice in terms of like, capturing the market initially and getting people into the space. When I joined, which was like late 2015, that was like, I don't know, 0.12 or so. It was still quite early, but even though I started like complaining about, some of these aspects of the JavaScriptness, it took us probably until 0.36 or 0.4, I believe, to get rid of it. Or maybe, I think 0.4 or 0.5. God, it's a long time. But anyway, one of the early things I really hated was the scoping rules, which were inherited from JavaScript, where you could just define a variable anywhere, and as long as it was in the same block, it was in scope, which is insane. We got rid of that, luckily. But there are like many other things I would have changed, or even today, to date, I still want to change. I would highlight like two pet peeves, which I think are going to unlikely to be changed, but I kind of dislike them. One is the ABI encoding in general. But one specific aspect I really dislike, it doesn't include the return types, which has, if you look at this ERC20 issue in general, it's also because of that. But there are like countless other problems around it. Now there's an argument, what if you include the return type, then can you just have, overloading of all these functions, and that's also like a bad idea. And in fact, if I want to like kind of detour, what is the reason behind how the ABI is, it's actually directly descending from how Solidity was designed. And I said it was like JavaScript-like, but at the same time, the biggest influence was in JavaScript. A lot of aspects, it was C++ and Python. And actually, this overloading aspect comes from the C++ side. How can you find, in overloading terms, how can you find the matching functions? And return types are not included in that. So that's the reason the API doesn't have it. But I wish it would have it. And even if it would have it, I don't think the language should allow overloading, to the extent it does. But the API should be more clear about that. And the second thing I kind of extremely hate, which is a cornerstone of Solidity, maybe hate is like a strong word, but what I would like to get rid of for a long while and move on from is inheritance, which is quite a big one. But yeah, there's a lot more I could say, but I'm going to stop here now.
Cool. Would others like to chime in?
About Solidity?
Yeah, I mean, just in terms of, so Charles, maybe a good segue as well, right? I mean, when you started looking at Vyper, designing it, I'm sure you've looked at Solidity and the design aspects, the implementation aspects, and trying to see what to pick and choose from. How did you go about that? I mean, are there any design choices from Solidity that inspired you to design and develop Vyper in a certain way?
So Vyper is in many ways, similar to Solidity. I mean, it's familiar to Solidity programmers. So one kind of security issue a lot of people are familiar with is like reentrancy. And so I was thinking about this. There's like a big tension between like complexity and security, right? Like the most secure contract is one that doesn't do anything. So, and there have been like, sorry?
Are you sure?
No, I'm not. But like there have been language design proposals out there which like don't allow effects until after all the storage effects, call effects. So like if you want to call to another contract, it has to come after storage, rights. And that's something we thought about for a while. But like in the end, you don't want to do that because smart contract programmers sometimes do want to break that. And, there's other techniques to get around that, like reentrancy locks and so forth. So, like, in the end, you end up trying to add features that help developers manage the complexity without, like, disallowing it completely.
Right. So maybe, Hari, would you like to add to something from the Solidity side? I mean, so we're going to mix this up, right? I mean, I know we have discussed a couple of ways of going about this. So Hari, I mean, obviously you've been contributing to Solidity for a long time now. And for people who follow Hari on Twitter, he's the optimizer. So you give him a contract and, he's going to optimize it to, I don't know, what's the 90% of the white code or gas usage. So what do you think of these design choices, and especially from a Spearbit perspective, right? When you wear your security hat, you obviously look at a contract differently, right? You look at the security, like Charles was saying, from a reentrancy perspective. How do you think from both sides?
Yeah, I would say the biggest challenge is always designing a language that's intuitive. Solidity has always been very, very close to the EVM. And the EVM, my number one recommendation to people who want to get deeper into stuff would be just to understand EVM. Once you understand EVM, a lot of the nuances of Solidity is immediately clear. The way something is assigned is obvious. But to give a specific example, look at the try-catch syntax in Solidity. It's only possible to do a try-catch on an external call. That's because that's the most efficient way to do it. But people somehow expect it to work somehow expect the try-catch to catch every single error in the contract context. We can, of course, implement it. You just have to delegate call the same contract and then just catch everything that comes up. But then you have a big overhead of call. You have to copy all the call data. So the question is do we want a feature that is efficient and as close to EVM as possible, or do we want a feature that's intuitive but comes with a huge overhead? So this is the big challenge for designing Solidity. And at some point you have to, make a decision, and it's never going to like make everyone satisfied.
So go about it iteratively, like how Solidity is going, right? I mean, new features are added, some are fixed, some are removed. So that is something that you see happening.
Yes, but at least right now, I mean, I do agree with Alex about how the language evolved from JavaScript into very strict typing. And right now we want to, like one of the biggest features right now is the user-defined value types. You want to make it as strong as possible, just having proper types for everything instead of just UINs, and increasing the type safety without any extra overhead in terms of gas.
Got it. So anyone else want to chime in on these aspects? All right. So maybe, so Grant, from a fee perspective, right? Fee as in the fee language, FE, right? Pronounced fee. I don't remember, I did read the origins. Maybe you can tell us more. I think it's from iron as strong and safe and secure.
Yeah, just a reference to the material iron. You know, it's kind of in line with like the name Solidity. Well, Ethereum or Solidity, people kind of like to choose these material names. So I just went with iron, and fee was nice and concise.
So it won't, over time, will it turn into Rust?
Maybe. Well, we'll see. If we do a good enough job, yeah.
So, great. So in this context, I mean, you've obviously, the origins of fee are probably fair enough to say it's more recent than Solidity and Vyper, yeah? So when you look at these two languages, I mean, are you sort of taking inspiration about what to do, what to pick and choose, or are you saying, no, I'm not going to look at them, I'm going to sort of lock myself up, put an air gap, and sort of design it from scratch, back end, front end, user experience, the whole thing? How do you go about design? I mean, a lot of us here, I don't know how many of us here in this room have designed a language. I have not, but we do have people who have. What does it take to design a language from scratch? What do you do? Do you think of the back end, front end, user experience? What do you do?
Yeah, I mean, yeah, I guess you're thinking about all of those things. Yeah, I mean, sometimes you look at like what Solidity does, and it's like, you know, maybe something is it's strange, but then you realize that there's, you know, a good reason for it. You know, like a good example, I think, is like you guys allow for like assigning constant values like during initialization, which, you know, looks kind of weird. Yeah, I'm trying to load this in my head right now, but you know, it's like you're doing this thing where you're not treating it like you know, like storage value or something. You're like putting it into the bytecode that you're deploying, and then you're using it from there, and that kind of requires you to do like some lower level stuff. You can't like yeah, I don't know. I'm not thinking of this example very clearly, but yeah.
But yeah, so it's I mean, I guess the takeaway for me is it's obviously all the aspects of the language, right? So it's not like it's a top down or a bottom up. You don't go start doing user surveys. I don't know how other languages are designed. They go Rust and a lot of these things that have happened to catch on a lot, right? But from a smart contract perspective, obviously, there's a lot at stake. I mean, if you look at the value captured per line of a smart contract, right? It's crazy. We'll get to that in a bit, but that's sort of my takeaway, right? I mean, it's.
Yeah, I'd say generally what I'm trying to say is that, like, you know, there are these nuances to compiling EVM code that you don't really think of initially. Like, you have this idea of like how the user is going to use it. And then you realize that there's some very technical stuff that's difficult to think through, and you kind of need to like hack something into the language that doesn't really fit with the model that you had intended. And yeah, I mean, we do look at like these other languages, you know, and see what they're doing, and they kind of like, you know, use it as a model as to how you should implement it.
All right. So we'll yeah, Alex.
Yeah, can I add?
Please. Yeah.
I mean, I fully agree with you. I just wanted to touch on maybe, you know, we did like maybe 3 or 4 times, we did like sessions where we came up with like entirely new language designs, and not just like, you know, iterating on the current language. every single time you start with, okay, now I know the language, now I know what people do, and now I'm like fully aware of everything. And you type down like one example, you know, like the basic, like the open example or whatever, more complex stuff. And you feel like, okay, this language now looks like perfect, and, you know, let's do this. And then if you start implementing it, you find out that you weren't as smart as you thought you were on multiple levels, because you don't fully know, you know, what people are actually doing, and that is also evolving quite a lot. And then you have to realize that there's a lot more behind the scenes than, you know, as in, you know, thinking about the syntax and the semantics, because there's so many restrictions you have from the underlying system. There are so many restrictions from the interactions between the different parts. And lately, especially the main driving force, you know, if you think of the fees and all that, the main driving force have been the cost and nothing else, right? How do you drive down the cost? And people at this point started to not even care about anything else but the cost, right? And yeah, I think it's extremely hard to design a language from scratch where you expect that you won't make like, you know, spend like multiple years improving it. Even if you look at outside of the blockchain, like Rust, as you brought up, you know, whether Faye would end up there. And in fact, like Faye has a lot of inspiration from Rust, language-wise. So I think it's a really good name, you know, and it's fitting. But if you look at Rust, if you look at the like initial version, it has nothing to do with the current one, and it had like maybe 3 major revisions to it. And you know, that's the hope as well with Solidity, that we may, and we didn't achieve that yet, you know, like having those big revisions. But if you set out to make a language, you're probably gonna end up with the same, you know, steps. You're gonna have major revisions, and if you're not prepared to do that, then you're probably not gonna be, you know, as successful as you think you're gonna be.
All right. So maybe let's switch gears. So we've talked about Solidity, we've talked about Vyper, about Fee, and we have Bryant from ApeWorks. We don't see him up on the screen, but that is him. We missed. Yeah. So Bryant at ApeWorks, right? I mean, you're a big Python maximalist, right? That seems to be the catchphrase, yeah. And you're using you're big into tooling as well in this space. So you've clearly used Solidity, Python, obviously, Vyper. You've been involved in some aspects there as well. So how do you see all this from, you know, at ApeWorks when you start looking at languages or tooling and framework from a usability perspective? How do you go about it?
Yeah, so I neglected to mention in my introduction that I've also worked on Vyper from the language design perspective for about 4 years. And I did want to sort of key off something that Axel had said, which is actually using the language and understanding how it worked. I think that's something Vyper got really right, and that a lot of the language designers over the years have actually used it in production settings and understand like what the issues are to solve. And that drove the design of the language. And I think that's kind of the only way that you can drive the language forward in using it. And it's probably easier for, you know, language like Rust, because people are building applications in Rust and they can design the language from that perspective. But with smart contracts, there's so much work that goes into, you know, thinking about how do you design this thing. And there's a lot of the developers that use it. It's like a very different experience in how you use it. Like I want to work with different standards, so ERC 20 and ERC 712 or something. Like you have a bunch of different ways you want to use the language, and people trying to work around issues that they find with the language in its current form kind of drives a lot of legacy infrastructure decisions. From a perspective of an integrator, there's a lot of things that have been missing over the years that people have tried to work around, like console log, right? So Hard Hat added a console log feature. It wasn't very easy for them to add it. They had to essentially write over 500 like functions by hand and then include that in a Solidity file that you include in your contract. And it's like a little, you know, a little onerous to get it to work that way. But, you know, it's a feature people want to have, and only for this like restricted subset of scenarios where you're debugging the design of something. And it's that's something you wouldn't think of right away. And as a language designer, you wouldn't think that that's something people would want or need. Why wouldn't they just use a debugger or stack trace, kind of go through it that way? But sometimes it's nice to have debugging. So there's a lot of things that I don't think people have a appreciation of when you're siloed in that design perspective, where as a user or as an integrator with the language, you have a lot richer understanding of how you would like to use the language and how that, and letting that kind of infer the design of the language is important, I think.
Yeah, I mean, so from that perspective, right, I'm sure we have many people in the audience, both here and online as well, who are probably all, coding up in Solidity today, right? Maybe it's fair enough to say about 99% of all the contracts are in Solidity, deployed on the mainnet, right? And there are, of course, some widely used projects that have been using Vyper, right? So from a centralization risk perspective, right, at a language level, right, how do you guys think about, how should we think about it, right? What if there is a major Solidity compiler bug, right? Which is also the reason why we have Vyper, we have Phi, and I'm sure there are multiple other languages being designed. So what are your thoughts? Charles, maybe to start off with you, right? Why should a developer write his or her next smart contract in Vyper from a security perspective?
Is this about security or centralization of the compilers?
We can start with security, but we can go down to the centralization as well.
I think there's a lot of reasons to use Vyper. Vyper has a lot of, in a lot of ways, it's a lot more restricted than Solidity. So we don't have inline assembly. That's a big thing. And when people, it's really interesting how feedback from users and over time as you get more experience writing smart contracts or interfacing with smart contracts, how that informs the language design. So people want to skip the X code size check or the return data size check, and maybe in Vyper what we've opted to do is add more options to external calls. Whereas, Solidity has, inline assembly. And so we do that. And then in Vyper, types are bounded. So it's a lot harder to do an out-of-gas limit attack. And we don't have inheritance. So it's a lot easier to trace the execution of a contract and things like that. From a centralization perspective, I think we probably all think about this a lot, what if there's a bug in the compiler? I think maybe, in an ideal world, in the C world, there's Clang and GCC, right? If one of them is wrong, you can use the other one. I think it would be really nice in the future if there were multiple Solidity and multiple Vyper compiler implementations. And, you could maybe even take the output of both of these compilers, Vyper 1 and Vyper 2, or Solc 1 and Solc 2, and compare them by hand even, see if they produce semantically equivalent bytecode. I think that's generally a very good way of finding out if the behavior is what you think it should be. There's multiple implementations, and that's I think something that the ETH2 teams have done very well. So there's all these implementations, and that's how they find bugs. It's different teams interpret the spec even differently, and then that comes out during testing.
Yeah, Grant, would you like to add to that from a fee perspective? As in, what's the status of fee? When is it ready? Can people start testing? And from a security perspective, what sort of features have been taken from Solidity or Vyper or even outside?
Yeah, well, if you don't mind, quick, I'll just go on the centralization thing for a
Please,
bit.
yeah.
Yeah, I think it's just better from a platform perspective to have multiple languages compiling to it, because that just, when people are writing AIPs, that means you're getting input from multiple groups with different designs. So I think that's just valuable for the community as a whole. As far as fee goes with security, Yeah, I mean, there just aren't, people like writing a ton of contracts with them. It's basically just us. Like at the moment, I'm like trying to formally verify a few like standard contracts. And yeah, I mean, it's just going to take time, like a lot of people have used Solidity and like, they're formally verifying the bytecode for their, the contracts they're writing. And, that'll find bugs within the contracts themselves, but, it could also find bugs within the compiler. So, just like the more people you have using it, the more secure the compiler gets, the more bugs get reported. For us, we're still like in this very early stage where we're just trying to generate like reasonably efficient code, reasonably correct code, and yeah, we only really know how correct it is until it's put to the test. Yeah, so like as I was saying, like at the moment I'm mostly focused on formally verifying some basic contracts. Once that's done, then we'll go into beta phase of our releases. Currently, we're in alpha, so we don't really recommend that people actually use it. But once we're in beta, then we'll start, saying that it's okay to use this. And I think we have a number of features already that make the language appealing. Like I think our module system is quite nice. I think it'll be nice when people can write like libraries and then share those libraries with each other, and then people can easily compile them into their projects. There's other things down the road. Like I generally hesitate to talk about anything that's like not implemented. But like, we're looking to support like constant generics, explicit immutability, or reference type. These things are like on the horizon. I think they'll be appealing to developers. Currently, access to function calls is provided by these variables that are passed in. You have the self instance that provides access to the contract state, and then everything else is provided through this context object, which is actually implemented in our standard library and is, operating on another module within our standard library, which just provides access to all of the low-level opcodes as unsafe functions. So, you can pretty much do anything in Phi right now. It's just we don't have things kind of like abstracted throughout libraries, and that's just going to take time.
Great. So let's maybe switch gears again.
Yeah, I can add a couple of things here.
Sure.
The first thing is I definitely agree that having multiple implementation and checking the output is a great way to like figure out if there are bugs in an implementation. I want to add that in the Solidity compiler itself, we actually have two different code generators. One is the legacy one, and the other one is the IR one. And we frequently find bugs by just fuzzing against these two implementations. This has been the best way for us to find compiler bugs before it lands to the release. And the other thing about inheritance, which I want to add, I'm not a big fan of inheritance, but it is one of the most successful features of Solidity. If you look at a typical contract, let's say an ERC20 contract, what they do is just inheriting from an OpenSupply implementation and just define what is the total supply, and that's it. So you can actually rely on somebody else writing a very secure contract and simply setting up a parameter. So on the one side, if you write contracts that have complex inheritance, perhaps reading the contract or understanding it becomes more complicated. But at the same time, it allows you to just inherit somebody else's implementation and just set a parameter. So it is this like complex design choice that doesn't have a simple solution.
Fantastic points. So yeah, in the interest of time, let's maybe again switch gears and come back to Bryant. From a user perspective, right, at ApeWorks, all the things you've been doing, what additional tools and techniques, right, language tools and techniques, be it the compilers, you talked about debuggers, we have static analysis tools, we have formal verification things. What do you think is required to enhance the security of Ethereum smart contracts?
So when you're designing it, and we kind of went into this, Hari was talking about differential fuzzing between the two different backends that they have, and I think fuzzing has been a great technique that has really come on the forefront in the past maybe year a lot more people have been exploring fuzzing as a approach in how they test the smart contracts that they're designing. It's like a piece of low-hanging fruit. You just kind of describe the inputs to the function, and you see if it matches your expectations of what it would do. Getting deeper into formal verification, like symbolic execution, and those kinds of things has been a lot harder, I think, for most developers to grasp. And they tend to rely more on tooling like static analyzers that do most of the work kind of at the tooling layer. And they just kind of handle, whether or not the output they get is a false positive or not. So, yeah, I mean, there's a lot of things in the toolbox, and it's continuing to evolve. And, as security professionals, we're trying to give more tooling to developers to do the work they want to do quicker and easier. I had something I wanted to feedback on to Hari's point, but there actually is a couple different implementations of Solidity. I think Nomic Labs is planning on making a new one, and there was I think
Solang?
Yeah, Solang, and then there was another one, right? There was a version made by the not Hedera Hashgraph, but what's that other?
No, it's Solang. Sol, yeah, with the two L's as well, yeah.
Oh, yeah.
SOLO, yeah.
So.
What is it implemented in?
Rust.
Yeah, I think most end up implementing Rust. Rust is nice because you can make very small binaries and distribute them very nicely. But the security guarantees that Rust and people think of when they think of Rust of like memory safety only really applies to the binary. It doesn't really apply to the code that it's outputting when you're processing the actual languages you're writing with it. So like, Phi could still have a bug in the memory allocation component of it, and it doesn't really have anything to do with Rust at that point.
I think Charles want to add something?
Yeah, I just wanted to add about multiple implementations is like it is kind of problematic in that if you have multiple implementations, then you have to have standards. And
we know how those work.
Right, and it kind of like makes you have to move slower. So in certain contexts, like in smart contract languages, I think right now it's actually very good that we have main implementations of each language because that means we can iterate quite quickly and respond to things as people learn more about smart contract development. It's definitely an emerging field.
Great points. So I think we should, we can keep going on. I have so many other things, and I'm sure people can dive deeper. But we'll see if anyone has questions for the people here, people who are, all right, Lucas.
Thank you. This question goes for Alex, because when he introduced himself, he mentioned that he dislikes inheritance. So could you please elaborate a little bit on that to hear the complete opinion?
I don't know, it's going to take forever, but yeah, I think Harry made a good point that it does enable composability quite easily, at least today, with all the tools available. Obviously, what else have we discussed beyond, inheritance? The Rust-style trait system comes into mind, and we did have a bunch of different ideas and designs around that, which is, it's not that far away from inheritance anyway. But the main issue with inheritance has been, which some of these have been resolved, but it has been, what is being inherited, in what order, what is being overwritten, and it's just a mess. But at least we have these override features, which resolved it a tiny bit. But then it's again just a big balance between having a feature and then trusting your users to use the feature well. And no matter what kind of feature you're going to do, the user's going to abuse it anyway. So it's a bigger part of an educational process, and with inheritance you can use it well, but it's education, and then the ecosystem has to also improve and find the good patterns to use it.
That's actually what I meant to respond to Hari's point before. Like the Open Zeppelin implementations, you pull them in, and there's actually a lot of bloat to them, and they end up using a lot of extra bytecode to kind of describe the different ways you can configure the features that the template has, and it's not really you end up with a lot of extra bloat that doesn't get used, a lot of unused code. And the compiler itself doesn't really have, like, it's seeing all of this layers of indirection, and it doesn't really know how to optimize that very well because there's just so much going on to it, right? Whereas a language where it's like more, like if you directly write the code in the language, like I want this and this and this, the compiler has an easier time of understanding that code and optimizing that code. So I think that's kind of been a failure of inheritance. Like, it isn't really a good way of describing like meta ideas. Like, I have an ERC20 token. I want it to have all these features. I want them to be kind of configurable in different instances, and it's not a very good way of describing that kind of behavior. So, like, exploring things like traits or different concepts from other languages, we can find a better zero-cost abstraction layer to that I think will be helpful in the future.
Great. I think we have time for maybe one other question. I thought there was a question here.
Hey, thank you guys for the talk. As a developer, the leap from writing code in a language and then understanding bytecode is quite large. And I would imagine that the leap of understanding bytecode to then creating it is even larger. Yet, nonetheless, many of us are very interested in doing that. How would you best suggest that someone like us would start contributing to some of these projects that you're making?
Just go through the code bases.
Easy.
I mean, I think that probably all of us, when we started contributing to our respective languages, we spent a lot of time just going through the code base and understanding it and like seeing, I spent a lot of time like mapping Vyper contracts to bytecode. I think it's very important actually if you're writing smart contracts to understand the bytecode that gets generated and how. And, I think that all of our code bases are quite good. So it's really good to understand the compilation phases, and you can just kind of like jump right in. If you're interested in Vyper, you can go in our Discord and ask questions. I'm sure the same goes for the other teams, but I don't know if they're as friendly here.
Yeah, just from a contribution perspective, all these are open source projects. They need a lot of help. There's usually issues with good first issue or needs help or something like that. And really diving into an open source repository that's so important, like compilers, it's a great way to learn more about the EVM and its behavior, and just like, level up your own skills. So, that's just a shout out. Recommend that you go to these repos and try them out.
I would just add one thing, that you actually don't have to look at the compiler if you're already writing contracts to just start complaining what you dislike or what you would like to see, and be engaging on the issue tracker. That is a really good way to start.
Yeah, I would also add, if you just want to start out like looking at the current language design proposals and making your comment on it would be great. And if you just want to take it one step further, you can actually look at how some of these features get implemented in the pull request. And the next step would be maybe like trying to build some of these features yourself.
Awesome. I think we're out of time, but this was a great deep dive. I mean, we have tons of questions on optimization, complexity. We could go on and on and on. But thank you all for joining us. And please give a round of applause to